Hi, welcome back. We're in lecture 21, and this is the second segment. And in this segment, we're going to look at data transformations. So in the last segment, we talked about these main assumptions that we've been making along the way throughout the course. And one of the primary assumptions we've made that placed a lot of constraints on what we could do is this assumption that the outcome variable y is normally distributed. So in the first segment, we looked at ways to detect violations of that assumption. And now what we're going to do is look at ways where we can fix our data set to make it be normal if we detect that we have a non-normal distribution. The way you do that is through a data transformation. So if a distribution isn't normal, then it's sometimes possible to transform the data set to make it normal. Now, a transformation is just a simple mathematical function applied to all values in the data set. For example, we could take the square root of every value in a distribution. And what's important about these transformations is they do change the values in our variables, but the rank order of the cases won't change. The distance between the cases may change, reducing, say, the variance and standard deviation, hopefully reducing the skew. But what's really important is that the rank order of cases doesn't change. That's what's key to doing a data transformation. So the most common data transformations applied for positively skewed distributions are the square root, the logarithm, and the inverse. And here's a picture of what those look like. So if we have a distribution that looks positively skewed, something like this, then a square root transformation might help to make it look more normal. If we have a distribution that looks something like this, then a logarithmic transformation might help to make it look more normal. And if we have a function that looks like this, then doing an inverse transformation may help to make it look more normal. If we have negatively skewed distributions, then all we have to do is reflect them, that is, take the inverse of all the values, and then apply the same transformation. So we could reflect and take the square root, we could reflect and take a log, we could reflect and take an inverse. So here you can just see the picture is just everything reversed. We're just going to reflect the distribution by taking the inverse and then do one of these transformations. So let's look at a couple examples. So here's a skewed distribution. You saw this distribution in segment 1. And I've printed here from the summary statistics the skew and kurtosis values. So here, this distribution has a skew greater than 3, kurtosis approaching 10. So we might say this is not satisfying the assumption of a normal distribution. So let's apply a data transformation and see if that helps. Well, here's the same distribution after I applied the square root transformation. Just take the square root of every value. You'll see we still have a sort of dispersion among the values, but if you look at the numbers, you get 5.5 versus about 7. I've reduced the distance between the values, which reduced the standard deviation. Notice it also reduced the skew. I'm now under 3 in terms of skew. It didn't reduce it that much, but it reduced it to the point where now I could say, well, this is normal enough for me to go ahead and do the inferential statistics that we've covered in this course. I could do even better, though, if I apply the log transform, right? Because you could see the shape of this distribution look better, that a log would do better. So here's the distribution after applying the log transform, and my skew value now is dropped to 2.69. So now it's falling more into the range of a normal distribution. Again, you can see it's not a perfectly normal distribution, but if the skew value is less than 3, a lot of people would argue it's good enough to go ahead and do all the procedures that we've talked about in this course. So let's do the same thing for a negatively skewed distribution. So now I just have the negative the skew going this way. I have a skew of negative 3.36. So again, it's over that threshold of 3 that makes me worry. Maybe this isn't normal enough for me to apply those inferential statistics procedures that we've covered. So let me apply a transformation and see if that can help. So I did the reflection and a square root transformation, and you'll see you got a skew value now below 3. If I do reflect and log, that does even better. That brings me down to a skew value of 1.59. So to summarize this segment, oftentimes you'll look at a distribution and you'll say, well, that distribution doesn't look quite normal, and you might look at the summary statistics and see that you have a skew value greater than 3 or a kurtosis value greater than 10, and you might want to apply a data transformation to see if you can make it look more normal, which will allow you to apply the statistical procedures that we've covered in this course. Again, the most common transformations are the ones I showed you: square root, log, and inverse. And for negative, you just reflect and then apply those same transformations.